Hi, in this video we will solve problems based on arithmetic progressions. So now let us go ahead and solve the first question. Aren't you bored of the routine problem solving session? I'm sure you all must be bored. So come on, let's make it more interesting for you all. We have a treasure hunt competition and you all will be given 5 clues. We have to crack all the 5 clues before we get the main treasure in our hand. So come on, let's get all geared up as we crack the first clue. So here is our first clue. Which term of the given sequence 23, 22 and a half, 22, 21 and a half and so on is the first negative term? Now don't get worried after looking at the clue. Let us first break down the clue. Let's see what is given to us. We have been given a sequence which is 23, 22 and a half, 22, 21 and a half. Now we need to find out the first negative term. Let us take a look at the solution. Now firstly observe the sequence. You will see that the first number is 23 and the second number is 22 and a half. Now we need to find out the common difference, which is D. Now how do we find out the common difference? We find out the common difference by subtracting the consecutive terms. So by doing that we get 22 and a half minus 23, which equals to minus half. So the common difference D is minus half. Now let the nth term of the given AP be the first negative term. We know that all the negative terms are less than 0. So we can write AN is less than 0. Now looking at AN, can you remember something? Yes, we remember the formula for AN, and the formula is A plus n minus 1 into D is less than 0. Now we have A and we have D. So let us substitute these values in the above step. By doing that we get 23 plus n minus 1 into minus half is less than 0. Now by opening the brackets we get 23 minus n upon 2 plus half is less than 0. By cross multiplication we get 47 upon 2 minus n upon 2 is less than 0. Now let us take n minus 2 to the right hand side. By doing that we get 47 upon 2 is less than n upon 2. By cancelling out 2 from both the sides we get 47 is less than n. Now this can also be written as n is greater than 47. Now we know that the value of n is greater than 47. So now 48 is the natural number which is just greater than 47. So let us take n as 48. Thus 48th term of the given sequence is the first negative term. So we have cracked the first clue. Let us go on to the second clue. So here comes the next clue. If the nth term of the AP be 1 upon n and nth term be 1 upon m, then show that its mnth term is 1. Now let us first simplify the question. We have been given mth term which is 1 upon n and the nth term which is 1 upon m. We need to prove that mnth term is 1. Let us take a look at the solution. Before we crack the clue, we need to have an idea of how we move about. We have been given 2 terms, m and n. So we need to first write down the expression for the mth term and then for the nth term. And then subtract equation 2 from equation 1. By doing that, we'll get the common difference, which is D. And then let us see how do we move about. So coming to the solution, we know that A is the first term and D is the common difference of the given AP. So let us write the expression for the mth term. That becomes am is equal to a plus m minus 1 into d. Now we know that the mth term is given by 1 upon n. So by substituting that in the above equation, we get 1 upon n is equal to a plus m minus 1 into d. Let this be equation number 1. Now let us write the expression for the nth term. That is an is equal to a plus n minus 1 into d. That becomes 1 upon m is equal to a plus n minus 1 into d. Since an is equal to 1 upon m, let this be equation number 2. Now, as we said earlier, let us subtract equation 2 from equation 1 in order to get the value of d. That becomes 1 upon n minus 1 upon m is equal to a plus m minus 1 into d minus a plus n minus 1 into d. By opening the brackets, we get a plus m minus 1 into d minus a minus n minus 1 into d. Now by cancelling out a and minus a and by opening the brackets, we get 1 upon n minus 1 upon m is equal to m minus 1 minus n plus 1 into d. Now again we can cancel out minus 1 and plus 1. By doing that, we get m minus n upon mn is equal to m minus 1 into d. We get the left hand side by cross multiplication. Now I can see m minus n on both the sides, so we can cancel m minus n on both the sides. By doing that, we get d is equal to 1 upon mn. Now let this be equation number 3. Now let us substitute the value of d in equation number 2. By doing that, we get 1 upon m is equal to a plus n minus 1 into 1 upon mn. Now let us take all the terms except a to the left hand side. By doing that, we get 1 upon m minus n minus 1 upon mn is equal to a. By cross multiplication, we get n minus n plus 1 upon mn. Now we can cancel out n and minus n. So a becomes 1 upon mn. Let this be equation number 4. Now we found out the mth term and the nth term. Now let us write the expression for the mnth term. So that becomes amn is equal to a plus mn minus 1 into d. Now we have the value of a and we also have the value of d. So let us substitute that in the above equation. By doing that, we get amn is equal to 1 upon mn plus mn minus 1 into 1 upon mn. We get this by using equations 3 and 4. By opening the brackets, we get 1 upon mn plus mn minus 1 upon mn. The next step becomes 1 plus mn minus 1 upon mn. Now plus 1 and minus 1 can be cancelled. So we get mn upon mn, which equals to 1. So amn is equal to 1. Hey, we cracked the next clue as we proved what's asked in the question. That is, the mnth term is 1. Wow, we've already cracked 2 clues. So let us see what treasure we've collected by cracking these 2 clues. We learned how to find out a negative term from the given sequence. We also learned how to find out the nth term. That is, we learned the formula for an, which equals to a plus n minus 1 into d. Let us crack some more clues in the next video. I hope you all understood these problems. In the next video, we will solve some more problems based on arithmetic progressions. Please visit www.letstute.com. Thank you.